remember what we said about arithmetic sequences before? Let me give you two lists of numbers up here.
What is in 32 days?
32 days of class left.
Only?
That's it. That goes fast. Okay. All right. Which of these lists up here is geometric? The first one or second one? First one, because it goes up by the same amount each time. We're always adding how much in that list? 3, okay? Guys, if you'll take a look at 7.2 titled Analyzing What Kind of Sequences in Series? Arithmetic sequences. This is going to be important. We are always going to be either adding or subtracting same amounts. Okay, everything is just going to focus on this arithmetic idea, all right? There's going to be some new rules that come with some things. I got to be honest with you, guys. 7.2 was going to be much, much easier than 7.1 was, all right? Okay. All right, first question. How can you recognize an arithmetic sequence from its graph? Well, guys, we've kind of talked about that already. What do graphs look like that are, how do I want to say this? What do graphs look like that are representative of arithmetic sequences? They're going to be linear. They're going to be straight, aren't they? Okay, we talked about that already. We've looked at points. So we kind of have a background knowledge for that. Stuff is going to be linear. And today we're going to start looking at how do you identify an arithmetic sequence? How do you write a rule for an arithmetic sequence? Turns out there's actually a formula to do this. You guys have been doing a lot of guessing and checking. Turns out there's a nice formula to use for all of them now. Okay? Now you're mad. I can see it. All right? And then the last thing is to find what? Finite. Does that mean it goes on forever or stops?
Goes on forever.
That would be infinite, right? So finite's going to end. Okay, we're going to find the sums of arithmetic series. But there's going to be some formulas and some ways to shortcut stuff. So there's going to be a lot of shortcuts. Let's review some vocab. First of all, arithmetic sequence. Anybody want to read that for me?
The expression.
An ordered list of numbers in which the difference between each pair of consecutive numbers is the same.
So like this list, 3, 5, 7, and 9. What's true each time, kids?
Going up by 2.
Going up by 2 each time. What's 5 minus 3?
2.
7 minus 5. 9 minus 7. What would the next number in the list be? 11. Okay. So it's a sequence that goes up or down by the same amount each time. Okay. A common difference then is the constant difference defined as variable d between consecutive terms of an arithmetic sequence. Above the common difference is what value? How much are you changing by each time? Positive 2. Okay. What's the common difference in this set? 3. D would equal 3 here, wouldn't it? Okay. Then an arithmetic series, it's just the expression formed by adding the terms of an arithmetic sequence. Okay, so this is just an arithmetic series is just a sum of your values. Okay, it's just the sum of your values. All right. We've already explored this before and talked about this, but guys, when we have an arithmetic series that's graphed or an arithmetic sequence that's graphed, what kind of graph do we get? Linear function. Everything's going to lie in a straight line. So it's going to be a function whose graph is a non-vertical line. And then the last thing here, kids, is this. Mean. I know your teacher's mean in 2 different ways.
That's my favorite Taylor Swift song.
Okay. She has that song?
Me?
Taylor Swift. I like Taylor. She's a good person. Mean means the same as what? Average. So like if I wanted the mean of the values 7, 4, 8, and 9, what would I do with these?
Add them and then.
Why am I dividing by 4?
Because that's how it turns.
Okay, that's how it works. What is the average of 7, 4, 8, and 9?
4. Nope. 7.
7 according to that, okay? So I think vocab-wise we should be in pretty good shape today, all right? So let's move on here. Let's take a look at some stuff here. Oh, this is so good. I love this stuff. I get excited about this, okay? Identifying an arithmetic sequence. First things first, kiddos. Tell me whether those 2 series or 2 sequences up there are arithmetic or not, okay? What's the difference between 5 and 1? In other words, what's 5 minus 1?
4.
What's 10 minus 5?
5.
Ooh. Arithmetic or not arithmetic? Okay, common difference is already changed, right? So this is not arithmetic. Okay. All right, let's check the next one. What's 1 minus 4? Negative 3, right? What's negative 2 minus the 1?
Negative.
Am I going down 3 each time? Am I going down 3 to get to negative 5 now?
Like it.
Am I going down 3 again?
Yeah.
Is this arithmetic?
Yes.
We would say that this is arithmetic because the common difference is what value? It's arithmetic because the common, what's the word I'm going to use after common? Difference, meaning one value minus the preceding value. 1 minus 4 was what? Negative 3. Negative 2 minus 1 is? Negative 3. Negative 5 minus the preceding value of negative 2 was what again? So on down the road. So the common difference is the same. It's always, oh, I can't even spell today. No, that was right, Parson. Difference, right?
Yeah.
Is negative 3. Okay, so we've talked about that already before. Sequences that are arithmetic, things that are geometric. That didn't really come up last section, but we kind of threw it in there. Let's talk core concepts. I love this, okay? I want you to highlight or call attention to this right down here.
That's so bad. That makes no sense. Highlight it.
Highlight it, circle it. This is really the big rule today, okay? There's going to be a couple of other ones sprinkled in there, but this is pretty good stuff today, okay?
What color should I use?
I don't care. Pink. All right, it says core concept. We're going to talk about a rule for what?
Arithmetic sequence.
Okay, it says the nth term of an arithmetic sequence with the first term being a, this should be a subscript like A1, yeah. All right, it says the nth term is equal to what, kids? It's equal to the first term, a of 1. This should be a subscript right there. Looks like a steak sauce the way it is. And a common difference, D, is given by a of n equals a1 plus what, kids? D times n minus 1, where n represents the number of the term, okay? So as an example here, kids, I have a list up here. I have a 4, and a 1, and a negative 2, and a negative 5, and a negative 8. And we'd like to write a rule for that list, okay? Well, here's how you do this, okay? What you really need to know, guys, is your first term and your common difference to be able to write a rule for this. You guys agree that my first term, A1, is 4? So my second term would be what? Third term would be what? Fourth term. Fifth term. Okay, if I wanted to write a rule, first of all, what's the common difference in this? D would equal what? We found it up above already. Negative 3, okay? It changes by negative 3, moving from left to right. What's your first term equal? Okay. If you wanted to write a function for an arithmetic sequence, or a rule for an arithmetic sequence, I told you there's a rule for this. Here it is. It becomes a of n, or the nth term, is equal to the first term, which is what? 4 plus D. So it's like minus 3 times what? Now, here's what we're going to have to make sure we do when we write answers for this, okay? You see that set of parentheses n minus 1 there, kiddos?
Yeah.
So it turns out we've got to distribute to make this look like slope-intercept form. So this is going to be the same as 4. Okay, help me distribute negative 3 here. What's negative 3 times n? Minus 3n. What's the negative 3 times the negative 1? Okay, so how about this value 4 and 3? Couldn't I combine them? Do you guys buy that right here, the nth term is going to equal, I'm going to put it in slope-intercept form, so negative 3n plus what? What's 4 and 3 going to add up to? Okay, so that's a plus 7. I don't like the way that looks. Make it a little better. Plus 7. Okay, so we've come up with a rule. Let's check and see if the rule works. Kids, plug 1 in for n in that function. Negative 3 times 1 plus 7. Plug 1 in. What do you get out? 4. Plug 2 in. Negative 3 times 2 plus 7. What do you get out? 1. Okay, plug the 3 in. N is 3. What should we get out for my third term? Okay, plug 3 in here. What's negative 3 times 3?
Negative 9.
Negative 9 plus 7 more is? Negative 2, right? Negative 5 is which term? The fourth term, right? So plug 4 in down here for your nth term. Negative 3 times 4 would be? Negative 12 plus 7 more would be? Is this working?
Yes.
Okay. Anytime you have an arithmetic sequence, if they ask you to write a rule for the nth term, what's the formula, friends?
A of n equals A1 plus B times n minus 1.
Okay, and do we want to leave it like that, or we want to distribute and simplify? Okay, let's check this out. Writing a rule for the nth term. Okay. In fact, what I would like you guys to do is do both of these on your own right now. All right. Just do the nth term for both. Don't do the a of 15. Just find the rule like we did above. Do that first. Okay. Once you've got an answer for both of them, let me know. To start you out here, guys, what's the first term in this one?
7.
What's the common difference?
3.
Okay, you guys write a rule for the nth term on this for me. And do the same with the second one, all right? Okay, anybody got a rule for this first one here? Or maybe what to start with or write?
3n plus 4.
3n plus 4?
Yeah.
Okay, how many have 3n plus 4 there? Okay, I'm just going to do the work down below. A of n would have been the first term, which was 7. Plus 3 times n minus 1, is that true? If I distribute here, isn't this plus 3n minus 3? Right?
Yep.
7 minus 3 is positive 4?
Yep.
I agree there. Okay. Over here in this second one, what's the first term?
15.
Okay, how about your common difference here? What's happening? What's the pattern, in other words?
Minus 7.
Minus 7. Okay, so I would set this up as a of n equals the first term, 15. Okay, plus my d value. So wouldn't that be minus 7 here? Times what? Okay, help me distribute here. 15. Negative 7 times n would be what? Plus 7? So a of n is equal to, I'm going to put it slope-intercept form. Can I call it negative 7n first? Plus 22? Okay, now I have a question right here. What's the y-intercept on this right here?
4.
If I put a 4 clear out in front right here, does that 4 fit the pattern right here? Like a y-intercept is starting like a 0 term, in other words?
Yeah.
Okay. What's the y-intercept on this one?
21.
If I put 22 out in front of this, does 22 fit the pattern of that sequence right there? Okay, so this would be like the point 022, this was my first term. Okay, so guys, now they go on and they say, hey, I want to know what a of 15 is, right? Well, what are you going to do to find the 15th term now, once you've written a rule for it? Yeah, so in this one right here, I want the 15th term now, right? It says find a of 15. So this will be equal to 3 times plus. Alright, and I have no clue what that is. What did you guys get? 49?
Yeah.
I like 49. 49 chicken wings.
I love chicken.
I love buffalo wings. I love buffalo wings. And you know what else?
What?
If there was one buffalo wing left in the world and it was between me and my grandmother,
I hate when you say that because it's so rude to your grandma.
she'd do the same thing to me to try and get
I
it.
don't think she would.
I think she would. She'd probably whack me with her cane.
I
You
don't
getting
know.
looked up, Hartman?
Tell me, I like chicken wings that much.
You like a lot of things more than your grandma can.
Yeah, it sounds a little concerning. It sounds like you just don't like your grandma.
I love my grandma. You're right, I don't like her, I love her.
Just
She's
not
been
as much
perfect.
as pie, chicken wings.
But when it comes to pie and chicken wings, it's to each their own. Every man for himself, right?
There's
There's
different
something
levels of love.
Guys, you know I would give it to her. I'm all talk. Okay?
Oh, we know.
What's the old saying? All bark and no
Like,
bite. Yep. Okay. What's negative 7 times 15, friends? Negative 105. Help me add 22 to that. I like negative 83. Okay. First question. Do you understand how the formula works?
yes.
You gotta know the first term and you gotta know the common difference, right? Once you establish first term and common difference, it's pretty easy to come up with some kind of a linear function to represent your arithmetic sequence. Once you've got your sequence, can you identify any term in the list then? Okay, if I wanted to know the 745th number in that list, what would I have plugged into each one then?
700.
745, very good, okay? Now give me a show of hands, how many are like, yep, I think today's actually easier than the first section, so
For
far,
now.
okay? So far. Alright, let's see what we've got, is this, are we ready for the next page, kids? Anybody need more time with that? Okay, friends, let's talk. Next page. Are we on page 3 right now?
Yes.
Okay, let's go up here and talk. Okay. This one here gets a little trickier here. It says writing a rule given a, not the first term, but given a what?
A term.
And then what else?
Common difference.
Okay, so let's read this right here. One term of an arithmetic sequence is 52. Specifically, which term is 52?
Well,
The 12th term, okay? It says the common difference is what?
6.
It says write a rule for the what?
Tenth term.
Okay, and then it says then graph the first 6 terms of the sequence. Where do you want to graph that? Okay, so I might have you guys do that for me. Well, let's talk about this. Do we know the first term?
Yep.
Well,
Ooh,
no.
we don't. We actually know the
12.
12th term, okay? Now, we know the common difference is what here, kids?
6.
Okay, let me just write this down here. Do you guys agree that the 12th term, A12, would have to equal my first term, which is A1, plus the common difference times n minus 1. But guys, if we're talking about the 12th term right here, what's the n value going to be in here?
12.
You guys agree with that?
Yeah.
Okay. Anything else I could plug into what I have up there then?
The difference.
Okay, watch this right here. We could say A12. Ooh, do I know what the 12th term value is?
Yeah.
Okay, 52 is the 12th term. Do we know the first term?
No.
I'm going to write A1 down here then. Plus, do we know the common difference?
6.
Now guys, I know that this was n minus 1, but why did I throw 12 up here?
Because it's the 12th.
12 terms. Help me out, kiddos. What's 12 minus 1 here? So isn't this 52 equals A1 plus 66? We said we could write a rule for the nth term arithmetically if I knew the common difference, which we already know is 6, and I had the first term.
Yeah.
Did they give us enough information to manipulate some things so that I can find the first term now?
Yeah.
Okay, how you gonna get A1 alone there, kiddos?
Subtract 6 and 6.
Alright, so you've got that. 52 minus 66, friends, is?
Negative 14.
Sam's always like the third one to say it. You're always the third one to say it.
Right? So let's come up with a rule for this. For the nth term. Okay, the nth term, A of n, would have to equal my first term, which is what, friends?
Negative 14.
Plus
6.
times.
And minus 1. Minus 1.
Okay, help me distribute over here.
6 and
Negative 14 plus 6n.
Minus 6.
minus.
How about that minus 14 and minus 6? Does that combine it all?
Yeah.
2.
Negative 20.
Okay, so A of n's rule would be
6 and
6n minus how much?
2.
Okay. Now, I'm going to put a table over here on the left. I'm not going to graph it, but I'm just going to give you the first 6 terms to this. Okay, but do you guys see what we did there to plug numbers in? Why did 52 go in here first?
Because it was the
That was the
12th term.
12th term. Why does 6 go in for D?
Because it's the common.
How come I didn't put a number in for A1?
Because we don't know it.
We didn't know the initial. Why did we put 12 up here for N?
Because that was the end number term.
12th was the 12th numbered term, okay? So we're gonna get our first 6. Who wants to do the 1 for me?
I got this
Who
one.
wants to do the 2? I'll do 2. In fact, we should be able to do this easily after 1, kids. Here's the deal. When I plug 1 in here, what's 6 times 1 minus 20?
Hold up. 6 times 1.
Negative 14. All agree?
Well, yeah.
The first point I would plot would be 1 comma negative 14 in, right?
Yeah.
So now think about this. This is all arithmetic, so the pattern's just going to go up by the same common difference each time. What was that common difference?
6.
So I'm just going to start going up by how much each time?
6.
So negative 14 should move up to negative what next? Negative 8 will move up to negative 2, 4, 10, and then what? Okay, let's just check the 12th term to know if I'm right, kids. What's 6 times 12?
60 or 72.
72 minus 20,
2.
50. Didn't they tell us the 12th term was 52?
Mm-hmm.
Is the rule that I wrote right here indicative of giving us the right answer up here at 52? Okay, so I'd say you're in good shape with this, alright? Okay, let's try another. Uh-oh. Writing a rule given what?
2.
Oh my gosh. This is so important. Okay.
That's why I said important.
Oh my gosh. What terms did they give you?
5 and 12.
Okay, so let's talk about this 5th term up here. Okay, I'm going to write this down as the 5th term. You guys agree that the 5th term, A5, would equal the first term, A1, plus a common difference of D times n minus 1. What would the n value have to be right here?
5.
5, right? All agree with that?
Mm-hmm.
I'm going to come back to that. Furthermore, do you agree that A12 has to equal the first term plus a common difference times n minus 1? What's going to go in for n in this one? Okay, so I'm going to cheat on this a little bit, okay? listen carefully to what I say when I do these, alright? I always believe that you should start with your higher term, okay? I want to make a note on this example here. Start with your higher term. And when I say start with your higher term, I'm saying start with the one that comes later in the order. So is the 5th term or the 12th term going to come later in order?
12.
So if I write start with later term, is that okay? Okay, so we're going to start with A12. Is that all right?
Yep.
Okay, what's A12 equal to, kids?
All of that.
So what could I plug in for A12? What value over here? Okay, so -8. That's going to equal my first term. Kids, do we even know the first term?
No.
Don't have a clue. So we just got to leave it as A1. You with me on that? Okay, next step. Plus, then common difference here. Do we even know the common difference?
No.
Or GERD?
Uh,
Do we know the end value?
yes.
What is the end value here?
-8 or 12.
12 minus what?
1.
1. Okay. Agree with that?
Yeah.
Okay, let's do the same thing now with the 5th term. What could take the place of A5?
-43.
Do we know A1 again?
No.
Do we know D?
No.
Do we know N, friends? 5 minus 1? Okay. We've plugged everything in to begin with here, right? Okay, do you guys agree that this becomes -8 equals A1 plus 11D? Everybody understand where the 11 just came from?
Yeah.
Okay, what's the next line going to be then?
-43 equals A1 plus 40.
Okay. Now guys, at the end of section 9.1, big ideas, I gave you some systems of equations that were rather difficult. There was like 3 variables in them on the end of those problems. I don't know if anybody messed around with them or not, but kids, here's how you handle this, all right? How many variables do we have to solve for right here? 2. But notice right here, what's the same in each equation? Okay, what we do here, guys, is this. Here's the deal. Kids, think about it this way. Isn't $1 equal to 4 quarters?
Yeah.
Isn't $10 equal to 2 5s? Okay, if I took $10 and subtract 2 5s, where would you be at? I don't want to do that. I'm sorry. If I took a $10 and subtracted $1, where would I be at? $9. Well, we said 10 was equal to 2 5s, right? If I took 2 5s and subtracted 4 quarters equivalency, where would you be at? 2 5s. Still be at $9, right? So what I'm saying is this. If -8 is equivalent to this mess on the right, and -43 is equivalent to this mess on the right, wouldn't -8 minus -43 equal this mess minus this mess?
Yeah.
We're going to subtract everything. Put a big minus sign down here. Now be careful on this, kids. Let me show you what happens here. We would go -8 minus -43. So this really becomes adding 43. So somebody go -8 plus 43 for me.
35.
Okay.
Thanks, Caleb.
This is where things get interesting. What's A1 minus A1 going to do to each other? It goes away. It's 0, right? Okay. 11D minus a positive 4D would make. And we made that A1 go away by subtracting those equations right there. What's that allow us to solve for?
D.
From this, your common difference has to be what, kids? D has to equal what value? Doesn't it? Okay. Now here's the deal. Once I've solved for D, I'm going to come right back up into here. I'm just going to kind of make a red line. This is important. I'm going to go back up into one of these equations we just had. I'm going to go back up into this one.
And plug in
What can I plug in for D now?
5.
So won't -8, I have to make some real, hang on a second. So from that right there, kids, won't negative 8 equal A1 plus 11 times what, kids?
5,
Which is what?
55.
That's how you can solve for A1.
Subtract.
So what's your A1 value equal? Negative 63, is that what I heard? Our job's to write a rule, isn't it?
Yep.
Okay, here we go. A of n equals the first term. Do we know that now?
Yeah.
Yeah, we got negative 63, didn't we? Plus the common difference, which is what?
5.
Times. Okay. You guys do the distribution on this, but when you get done, you should end up with 5n minus 68. Okay, now check something here, kids. What two terms did we have over here?
Negative 43.
Okay, and that was the fifth term and the 12th. Plug 5 in down here, please. What's 5 times 5?
25.
Do 25 minus 68.
Negative 43.
When I plugged 5 in, I got negative 43 out. Is that good? Okay, plug 12 in here. Guys, what's 5 times 12? 60 minus 68 more would be what? When I plugged 12 in, did I get the right value out? When I plug those two values in, that works. This must be,
True.
it's got to be correct. Okay, it's got to be correct. Right? All right, let's see what else we've got here. That's a pretty tough one. Now notice what I put up in parentheses there,
I found the
kids.
difference between 43.
What did I put up in parentheses?
Important.
Importante. All right. Very mucho importante.
Common difference of
Do
5.
you think we're gonna get through all this?
Oh heck yeah.
And then I would just.
I'll just keep you till about 4 o'clock today to do that.
Oh, heck no.
And then it was 5n.
You don't want to hang out with me?
I wanna go home and eat ice cream.
My heart is broken today,
I
guys.
just wanna
I'm
go
sad. Okay, I would really like to get through this right here. Sum of a finite arithmetic sequence. So let's see. What this is saying is this. So we know how to get lists put together, and we like to add things up. But there's actually a rule that saves you a ton of time, and it's a pretty slick one right here. And I'm going to rewrite this rule because it should be more like this. It should look like S of n. The sum of that series is equal to n times a1 plus a of n all over 2. Now guys, n represents what again?
The term.
Number of terms, right? This a1 would represent my
First term.
first term. Now if n is the last number in a set, then a of n must represent the
Last.
last. Okay, let me give you a little sequence here. We'll finish this example up and we'll call it good today, all right?
Yes.
Okay, so give me an arithmetic sequence right now, kids. Give me about 5 numbers in this arithmetic sequence.
1, 2, 3, 4, 5.
Good God, pick something more excruciating than that. How about we go up by 6s? Is that okay?
No, right, 800 though.
I'll go up by 5s. Is that all right?
Sure.
So what's the next one?
Oh, I think
16.
21. Now, guys, all right, we've got an arithmetic list here, right?
Right.
So that sequence is arithmetic. We want to be able to find the sum of this. Now, I don't want to be able to just say I have to add them up because these lists can get kind of lengthy. Is it possible I might have like 56 numbers in there?
Awesome.
Adding 56 numbers in the arithmetic sequence would get very time consuming, okay? There's a rule that says this. It says the sum of a finite series. Let's just do this real quickly. Add this up for me. What's 1 and 6 add up to?
7.
And 11 more is?
18.
18 and 16 would be? 34. 34 and 21? This is going to add up to 55, right? Okay, now again, keep in mind, this only works for what kind of a sequence? If a sequence is arithmetic, you can easily find the sum of this list by doing the following. We would have S of n equals, okay, how many terms are in this thing, kids?
5.
Okay, so we really have the sum of all 5 terms here, s of 5 equal to n. So what's my n value? How many terms are there? 5 times the first term, which is plus the last term, which is all over what? Okay, let's do some math. In parentheses up here, what's 1 plus 21? How about 22 divided by 2? 11 times the 5 out front is? Oh my gosh, isn't that what we thought we would get? Okay. Alright, so we're going to pick this concept up here tomorrow. We're going to pick this up tomorrow. There's a couple of more things that we need to do, but kids, okay,
I'm not gonna. Matt,